Okay, as I said, every biological signature is there. These are like tubing. As I showed you, the heart has all these tubes that run out of it, and of course you have to flex and move around, and that's how they're built, just exactly like that. Of course, this would be coated, as that was at one time. And you can see the black and the red. You've got the vein and the artery. It's everywhere has the same sort of biology. I mean, that's biology. Okay. The truth of the matter is that sandstone is not just sand, it came from nowhere. Sandstone is eroded body parts. This is considered sandstone. I don't think any geologist would say that's not sandstone. However, if you know what to look at as an anatomist, you will understand that is a bone emplacement, more than likely. And that is the central core of that bone emplacement. And this is the tendinous material that glues into that bone emplacement. And then from that tendinous material, it goes into the muscle. The muscle becomes very fibrous and breaks quite easily after a certain distance of time, which is called the abrupt transition. As it demineralizes, it's very tough right here, and it's extremely tough in the tendon. And then, of course, the bone is the bone area. And then the outside is extremely sand, and the inside is a muddy layer of bloody, sandy, and then this is the connective tissue. Uluru, and I don't mean to have any disrespect for Uluru. I know it's a tribal, it's sacred. And I don't mean any disrespect. I'm going to call it Ayers Rock because I have a hard time sometimes saying Uluru. Anyway, the people that live there know about it. They understand it. I don't think they. I don't know. I don't know what they know, to be perfectly honest with you anymore. I don't know. People have been so indoctrinated to believe things that just aren't even close to true. And now they will defend them to the death. I mean. And this is nothing more than a bunch of blood right in here. This I've shown this in the microscope, and you know it is what it is. And these structures are all over our Earth. It's not just Uluru. It's the Grand Canyon. They're everywhere. And the creatures were, if that's the heart of a creature, that's a pretty good sized creature. All right, and I've found all the digestive system and everything over there in Australia. It's very obvious once you know what to look for. So let's just take a quick look at what I have to show you, and then you can go on your own. Okay, my outstanding friends, this is going to be a quickie. That is Uluru, Ayers Rock in Australia, and it is a heart. That is heart muscle tissue. This is a lung. This is also a lung, and everything can deteriorate to a point where you can see the internal fabric to it, which is this is a lung. That is the red blood of the lung. It has deteriorated to a point where all the blood is flushed out of it, similar to this. Mostly all you have left here is the structural component. This still has everything inside, blood and everything. This is a bone. All of this stuff will turn into rock. Just like Ayers Rock. This is a goose head turned into rock. This all happened because of the Great Flood. That's a piece of meat turned into a rock. That's a fingertip turned into a rock. And that is the blood that exited the artery. I've studied this extremely well. That is a heart, and that is Ayers Rock. And I've looked at well, let's take a quick look. Now there's Ayers Rock. That is not somebody came up there and dug all these little things out of there. This is the biology of heart muscle stripes. All right, it contracts. It actually twists. I'll show you what the actual biology looks like, and I'm going to show you a couple of close-ups of things that look virtually exactly like this. They have holes all through them because they have bled out. That's why everything is so red around here. That's blood. That's blood cells. All right, this is a lung, but a lung is nothing more than attached to a heart and lung together. And they pump the blood through, the lung gets reoxygenated, and it gets pumped through your body and so forth. Right there I'm going to show you the exact same stuff, the red and the black. The black is vein blood. You see that? That's a vein. Everywhere there's arteries and there's red blood, eventually you use that oxygen and it turns black. Or in mud fossils. In the body, it's more of a blue. But I will show you this in a microscope in a second. You can see exact same stuff, identical, no difference whatsoever. Only this is a lung, that's a heart, and this is a little smaller. All right, I got the lung in the microscope. Don't forget, you got the black and the red. And that's what you got right there. This is the lung. These little holes are the alveoli, and the black is the deoxygenated blood. This is where it's getting reoxygenated. Simple as that. And the same thing happens in the heart. Well, the heart pumps it. Let me show you something. Let me show you the anatomical. Hold on. All right. A lot of people aren't familiar with this, but the heart is right here. It works in conjunction with your lungs, and then it sends all of the byproducts to your liver, to your spleen, to your kidneys, to your digestive system. All of that stuff migrates around. You see the red? This is the arterial side. You see the blue? This is the side that comes back after it's been, all this stuff's been used up or been processed and cleaned. So that's the way your circulatory system and lymphatic system work. And what happens inside of here? All of these different juices go in there, which are catalysts and enzymes and so forth. The heart is primarily a pump. The lungs transfer oxygen and carbon dioxide primarily. These other organs do all kinds of things and add secretions of all these different lymphatic juices, and they break down molecules. Now, the only way they can do that is by bacteria. The bacteria has to be living in these organs. We don't know what lives in here. We need to find out what lives here, 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 here. And I mean, it's going to be everywhere. It's going to be different because every one of these has a different function and has to create a different product. Simple as that. All right, you've seen the heart muscle. This is what heart muscle is. And they make these little blocks and they constrict, and that's what pumps your blood all day long for 24 hours a day. Or you're dead. Okay, this is basically what you see in the Ayers Rock. And this stuff just dissolves. It's a watery substance. It dissolves in the open environment. All right, now we've seen all the muscle fibers and so forth, but there's attachments, there's little tubings come in here and there, and that's all seen as well.